Let's do a couple of examples of using the scalar product in Cartesian form. So the first question is, if you want to find A dot B, you can see already that we've got our vectors identified. So, and because they're in Cartesian form, then applying the formula is actually quite simple. So A dot B, if we're going to recall that, is A1, B1 plus A2, B2. So in this particular example, we've got A1, so I'll just write them over here, so just to make it very clear. So I minus 4j can be written as a column vector 1, negative 4, and B is 2i plus 3j. You don't need to do this once you get habit, but as this is our first example, I'm making it explicit. So A1, A2, B1, B2. So effectively we're going to have 1 multiplied by 2 plus negative 4 multiplied by 3. So 1 times 2 is 2, negative 4 times 3 is negative 12, which gives us negative 10. So our scalar product of A dot B is negative 10. If we look at this second example, A plus B scalar product with C, dot product with C, just like it is in most problems, if you see something in brackets, you do it first. So A plus B, so we'll do that first. That's going to be equal to I plus 2i is 3i, and then negative 4 plus 3 is negative 1. So A plus B is going to be equal to that. So therefore A plus B dot C is going to be, pardon me, 3i minus j dot product with C, which is negative 2i minus 2j, which we're going to go with as 3 multiplied by negative 2 plus negative 1 multiplied by negative 2. Running out of space, I'll just do it here. 3 times 2 is negative 6 plus 2, negative 4. Pretty simple. Okay, the third example, the angle between A and B. Okay, so first thing we need to do is, if we want to find the angle between A and B, then we need to use the relationship for scalar product that includes angle, which is this one here. Okay, so we're going to find the magnitude of A. Well, I've got A just at the top of the screen, so I can still see that. So the magnitude of A is going to be the square root of 1 squared plus negative 4 squared. Okay, so 1 squared is 1, 4 squared is 16, so that's going to be square root 17. Magnitude, very ugly. Magnitude B is going to be, B is up here, so it's going to be 2 squared plus 3 squared. 4 plus 9 is 13, so we've got square root 13. Pen's not working at the moment. Let's get it going again. So once we've found those, we've already found A dot B. So A dot B was found in question A up here, so that's negative 10. So what we can now do is put in our values. So we know that's negative 10. We know that's root 17 multiplied by square root 13 cos theta. So cos theta is going to equal negative 10 over root 17 multiplied by square root 13. Now, using our calculator, we can see what that's going to give us. So my calculator gives me 132.3 degrees. Okay, so let's have a look at A and B. So if we think about, let's just see if that makes sense to us. We'll just expand this out a little bit so we can see it. So we draw that out and draw vector A, which is I minus 4j. So I and then minus 4j. So it's going to be down like that. Oh, no, it's not. It's going to be I minus what? It's going to be down like that. Apologies. So it's vector A. Okay. And then it's probably like a lot steeper than that. And then 2 plus 3. So 2 plus 3. So 2 plus 3, it's going to be something like that. Okay. And I'm going to redraw A because it just makes it a little bit more accurate. It's probably more like that. Okay, so there's B and there's A. We can see that that angle is greater than 90 degrees, so our answer of 132 makes sense. Okay, so the third and final example that we're going to do here is we've got A, B, and C are points defined by the position vectors A, B, and C respectively, where A is that, B is that, and C is that. Find the magnitude of angle ABC. So what we need to really identify is, well, what does that even mean? So the first thing we need to do, I think, is draw it. So we'll draw in a set of axes, and as reasonably accurately, oops, I might use my INJ here, reasonably accurately as I can, let's mark these vectors on. So I plus 3j is going to be something like that. So that'll be my A vector. So that will be point A. Okay. B is 2i plus j. So 2i plus j will be something like that. So there's B. Okay, and I'll draw that vector back to the origin there like that. And C is I minus 2j. So same distance out there, but it's down here. Not quite as far as the first one. And there's my C. Okay. And the question wants me to find the magnitude of angle ABC. So if you remember back to middle school maths, okay, we want to know that angle there. Excuse me. So if we want to define that angle there, we need to define the vector going from B to A and the vector going from B to C. Okay, so let's call that vector, just for something to call it, let's call it vector M and vector N. Okay, just you can call them anything you want. All right, I just didn't want to use A's, B's and C's. So vector M will be, going from B to A, it's going to be A minus B. Okay. So that's going to be I plus 3j minus 2i plus j. So I minus 2 is minus I, 3 minus 1 is 2. And then vector n is going to be C minus B. So if we go from B to C, okay, remember vector n is BC, vector m is BA. Okay, so therefore we're going to have C, which is I minus 2j, minus B, which is 2i plus j. So we subtract that, so I minus 2i is negative I, same as the other one, and then negative 2 is minus 3j. So there's my Mn. So now I want to find the magnitude of that angle. So I need to do m dot n is equal to magnitude of n cos theta. So a few things that I have to calculate here. You'll notice I need m dot n. So the first thing I'm going to do over here, m dot n is going to be negative 1 times negative 1 plus 2 times negative 3. So that's going to be 1 minus 6, which is negative 5. I also need the magnitude of m. So that's going to be 1 squared plus 2 squared, which is 5. And the magnitude of n, which is going to be 1 squared plus 3 squared, which is 10. Square root it. So now we can put our values in. So now we've got negative 5 is equal to square root 5 multiplied by square root 10 multiplied by the cos theta. So theta, I looked at the whole thing. Cos theta is going to be negative 5 over root 5 times root 10. And then using our calculators, I get exactly 135 degrees. Okay. And so that's our solution to that problem. So therefore, angle ABC is equal to 135 degrees.